text message, mind you. So it's really cute. So let me make it as big as I can make it on my end. Okay, so there's our our crooked title there. So 7.4 special products. And then the first thing I'm showing you is a perfect square trinomial pattern. So write those down. You should see a pattern there, but I'm going to let you write them down first and then see what you notice about that. So once you have that written down, tell me in the... All right. So remember, again, I copied hers, so it's a little different than when she's doing notes, so I apologize. So I want you to write down this example first. So we got 9x squared plus 12x plus 4. And notice that, we're just looking at the orange, don't worry about that black right there. So we're noticing here that this number 9 and this number 4, those are perfect squares, right? Because 3 squared is 9, right? Or 3 times 3, however you want to say it. And we know that 2 squared, 2 times 2, right, is 4. So when we're squaring something, it has to be the same number. So if we're given like 36, it would have to be a 6, right? Because 6 times 6 is 36. So that's what a perfect square is. Go ahead and write that down. Don't write down this black yet. We'll get there. I mean, unless you want to pop that in, but that's part of our problem here, working it out. Okay. So let's look at some more. Okay. I want to look at this orange right here. So if this is a perfect square trinomial, the number that multiplies to a times c will be the same. So we're not going to have to hunt for numbers as much, basically. So she used 36 as our example. 6 times 6 gives us 36, right? It's a perfect square, so we know they're going to be the same. Okay, go ahead and write that down. Once you have that written down, tell me done in the chat. I forgot to record that, so I'm just going to say that again. So here is our equation written out with our 6's. So 9x squared plus 6x plus 6x plus 4. So now just go ahead and solve it and give me your answer in the chat. And if you're stuck, then what pattern? I forgot to hit record. I hate when I do that. Okay, so if we look up here, so now this maybe makes a little bit more sense, right? Why they got that squared. So if we get, when we work it out, if we get the same thing in each one of our sets of parentheses, we're going to write it out just like this. Any questions on that? That's really the only thing different. We're dealing with squares. So not super different than what we've been doing. Okay, so that is called a perfect square trinomial. Okay, we got some more notes. Sorry, I didn't do them all. Let me know if we need to wait. Oh my gosh, I'm just gonna have to keep recording because I keep forgetting. Okay. So again, 9 squared, or 9 times 9 gives us 81, right? And then 4 squared, or 4 times 4 gives us 16. So we know those are square roots. So to find our numbers, remember, we still have a times c. So this is a, remember, this is b, and that's c, right? So we still have our a times c, which is 81 times 16. That gives us this big old number, right? 1,296. And then our b is our negative 72. But it shouldn't take us too long to find our numbers because remember, since these are squares, right, we know we're going to be dealing with the same number. And to find that same number easily, you guys, you could just do the square root of our number up here. So if we did square root of 1,296 on our calculators, we should get 36. And they both have to be negative because a negative times a negative gives us a positive, right? And then if we're adding a negative plus and a negative, we're going to get our negative. And it has to be a negative 72. So it should be negative 36 and negative 36 is our numbers. Okay? And now the same stuff we've been doing. We're just writing it out. Now it's going to look like 81y squared minus 36y minus 36y plus 16. Mine's zoomed as it can, but if you pin my picture, Juliana, it'll make it the whole screen size. You won't see anything else, but it'll make it the whole screen size. But I have it as big as I can on my end, so.
I think it's just the orange pen color.
Yep.
It's kind of hard to see.
It might be. Let me go this way. We won't be able to show much of the page, but we can try this. My thing is that better? My thing is so funky. There we go. All right. Okay. So write that down. And then I want you guys to go ahead and do our last two steps. Remember, we have to break this up and then break this up. So these are together, these are together. We're going to find that GCF. So I want you to find the GCF. And let's actually try telling me what that GCF is going to be first, and then I'll have you go from there. So when you guys have that, let me know what that is. And I forgot to hit record, I swear. Some days I'm on it with the record button, and then some other days I'm just not. All right, nice job. Anybody have any questions on that one? No? Okay, I got a couple no's, got a few no's. Awesome, awesome. Okay. So I think she gives us, we have a lot of notes, you guys. I'm sorry. Okay.
You mean both me once, like I'm still writing
Yeah.
it down.
Yep. Hopefully we don't have orange on this one. I don't think it is. Oh, yeah, we do. Okay. I'll zoom in again like this. Melise is lagging, I think. I think it means lag you. Lag you. I don't know. Maybe. All right, are we ready? You're still writing?
Yeah.
Okay. Let's look at our next example. All right, let's write down our problem first. I'm going to move this up so I can zoom in. I'm just going to get rid of that. So if you need it, I'll go back to it later because the orange is still here, guys. So 64y squared minus 80y plus 25. And we're going to check and see if that 64 and that 25 are, it can be a square. Oh, I'm sorry, Cheyenne. I don't know why. Is it just me or is it Miss Myers too? Now you're making me feel bad. I got good internet over here, man. It should be great. All right. So let's look at 64. So yes, that's a square, right? Because 8 squared or 8 times 8 gives us 64. Or if we did the square root of 64, we'd come up with 8, right? Same with 25. 5 squared or 5 times 5 gives us 25. Square root of 25 is 5. So we know that these are squares. Okay, so if we're looking at our chart, we're just going to do our A times C, which is 64 times 25, which gives us that 1600. Remember, like on the first example, just square root this, and you're going to come up with your number. You should get 40. And again, this is a positive, so these both have to be negatives, because when we multiply a negative times a negative, we get a positive. And this one's a negative 80, right, our B. So we know we're going to have negative 2 negatives also, because when we add those up, they're going to still be negative. Okay, so we got our numbers. We got our numbers. What is this crazy green she's got down on here? All right. Oh, she wanted you to notice that when we found our, I got ahead of myself and did our GCF. Don't act like I didn't show you that. Act like I didn't show you that. Okay, write out your equation. 64y squared minus our 40y minus our other 40y and then plus 25, right? And then I'll show you what she means when you find your GCF. Tell me what you guys get for a GCF. So Cheyenne, am I only lagging or is it Miss Myers too? Just curious if it's my internet or hers. I don't know. Oh, let's see. Yes, 8y and 5. And if you notice, our 8 came from up here and our 5 came from up here. Is that true for our last one? Yes, it is. So quickly, I don't worry, I won't stay here long. If you look here, our 9 got pulled there, and that 4 was there. So kind of a little trick for you. Guess you can check your work and know that you should get that. All right, so let me know, guys, what you get for your answer or when you reduce it here. So we have an 8y and a negative 5. Is that GCF? Nice job on these. Any questions on that, guys? I'm thinking we've done this so much that it's pretty good. Hey, Miss Myers. We're on our last page, Miss Myers. We've had a lot of notes. All right, guys, can I move on? Perfect squares. So the difference of two perfect squares. Let's look at that. I'll give you a second to write that. I was lazy, Miss Myers, and I copied your notes down because I didn't feel like writing them last night. 2 more examples, Donovan, I promise. 2 more.
And these ones are really quick.
Yes. All right, let's look at this. Let's look at x squared minus 1. And now that I copied your notes, I'm regretting it because, you know, it's harder. But I was just lazy last night. I already apologized to the children.
Oh, that's good.
Yeah. So x squared minus 100. Huh. Okay. That one looks a little funny, right? Okay, we notice it's a subtracting problem. Great. But there's no b term, right? That's okay. We're going to see what we're going to do right now. Okay. So remember what we were doing before. We were checking to see if we had any numbers that we could, or that were like a square number, right? So same thing here. That's a 1. So 1 times 1, or 1 squared, gives us a 1, right? Okay. And if we're looking at this 100, we have 10 squared, or 10 times 10 will give us 100. Remember, you can just square root that to find that out if you don't know what it is. So if we're going to rewrite that problem now, we're going to get x squared plus 0x, right? Because we need to have all our terms in there, right? We need to have our b term. So we can't get rid of it, but we know we have our x and there's no number. So 0x minus 100. And I think we have a side note. Yes. So we're going to add in 0x for 0 or 0 for b. That's where our 0x comes from. And I think we're going to see a couple of these on there. That's why we're throwing these at you. Make sense so far? Any questions on how we went from here to here? Nothing? We're almost done. I promise. All right. So let's do our magic here. Okay. So there's our. See, this is why I have to write them. Okay. So let's do our chart. We have our A times C. So if I go like this, our A is 1. Our C is that negative 100. So we multiply this together. We get a negative 100. And then our B is 0, right? So, remember, we can do our square root of our 100. We should get a 10. But we need to multiply to get a negative and add to get a positive. So we're going to have our negative number and our positive, right? If we multiply that, we get a negative 100. If we add it, we get a 0. So those are our two numbers. Then we want to write it out. So now it's going to look like our x squared minus 10x. Remember, always do our negative first. Our negative 10x plus 10x minus 100. And then I want you to tell me what your GCF is when you find that out. Let me know in the chat. All right, Milani says yes. Sorry. Okay, I'm not holding on anymore. Okay, so we got, let's see. Ooh, all right. Okay, I see, Anis, what you did here. But Anis, did you notice that we ended up with a negative and a positive. So when we pulled this out, we had our x out here. We did our division, we got x. Did our division here, we got our negative 10. Then we brought down that 10 that we got there for our GCF, right? We did our division of 10x over 10, leaves us with an x. And then our negative 100 over a 10, which gives us a negative 10. So we have x minus 10 and x plus 10. So that one we won't write with those parentheses and squared because we have two different signs, right? Yep, you got it. That's cool because we did all those other ones like that, so, you know. All right, so any questions on that one, you guys? Do you see why we're not doing them in parentheses squared, right? Because of the different sign. Same numbers, but different sign. Okay, we got one more. I know. Don't grumble. One more. Okay, can I go on to it? We good? I don't have to wait? Okay. All right, all right. Let's look at this one. Okay. So 16x squared minus 49. And again, remember, we're going to check to see if we have a square number here. So, remember I said you can just do the square root of 16. You should come up with that 4. So 4 squared, or 4 times 2 is 16. And then 7 squared, or 7 times 7 gives us 49. So, we know we got that. So let's now add in our b that we have to do, right? We need our b term. So let's add in that 0x. So we'll rewrite it as 16x squared plus 0x minus 49. So remember, if you're given a problem without that b term, we've got to put it in there. We can't forget that. All right, so in our little box, we want to do a times c, so 16 times negative 49. Wouldn't that give us a negative 784, Miss Myers, or you just didn't write it in there? You just didn't write it, huh?
Yeah.
Yeah, okay. But we're good. But these numbers will still be good. Okay.
Yeah.
Just want to make sure. Okay, and then remember our b is 0. So we have to multiply to get negative and add to get a positive. So again, we have our negative and our positive number. And remember, we just did square root of that 784 to get that 28. Okay? So negative 28 and 28 are our numbers, because if we add them, we get a 0 too, right? So that's where that comes from. I like this because we don't have to find as many numbers, you guys. It's kind of cool. Okay.
And that's what's nice when you recognize your perfect squares. It helps you to find those numbers real quick.
Yep.
Because these problems can get kind of like big numbers.
Yeah, look how many we would have got all the way to 28. That would have taken us forever. So, yeah. All right, so if we're rewriting it, 16x squared, put your negative number first, so negative 28x plus 28x minus 49. And then tell me your GCFs. Remember, we're going to do our GCF of 16x squared minus 28x, and then 28x minus 49. Use that 4x and that 7 and tell me what you get for your answer. Agree? All right. Let's look. Nice job. Okay, so we brought down our 4x that we got over here. Then we did our division, 16x squared divided by 4x, and we got our 4x. Negative 28x divided by 4x, we got a negative 7. Then we bring down our 7 GCF over here. And we do 28 divided by 7 to get that 4x. And then negative 49 divided by 7 to get the negative 7. So when we write it, we're going to take our 4x minus 7s, right, and put that there, and then we have our 4x plus 7. So same numbers, different signs, so we're going to leave it like that. Okay, any questions, guys? One more page, just kidding. Okay, let me just minimize this guy here. I want to look at what we should be doing now. Let me stop recording this.